Hi folks, I'm going to show you today how to use the LIGGHTS open source discrete element method solver as a module that you can import in Python. The general idea being that you can use a single Python script to perform both simulation and post-processing or analysis. First step is to download the LIGGHTS public source code from GitHub. Now I'll provide a link to the repository in the description below. If you copy this link, then go to a terminal and use git clone and paste the link. The source code will be downloaded in a few seconds to a few minutes, depending on your connection speed. If you don't have Git set up on your system, you can always manually download the source code as a zip file, and then you extract the files. Now that the download is complete, we're going to change directory to LIGGHTS public and list all the directory and files here. And it's the source directory that contains all the C++ and the header files, as well as the make files that we need to compile LIGGHTS. So we change directory to source and list all the files. You're going to notice that we have a lot of header and C++ files, as well as the make files. And the first step in compiling LIGGHTS as a shared object is to invoke make shlib, which is going to generate the necessary files to compile LIGGHTS as a shared object. Now, since I'm using version 3.8.0, compilation requires a whitelist of different contact models that are used in the DEM simulation. And there are many ways to generate this whitelist, but perhaps the easiest way is to simply compile LIGGHTS as an executable. And in this version, the compilation is quite easy with the auto keyword. So make auto will simply compile LIGGHTS as a static executable file, and it's going to figure out the different settings on my system, if there's MPI installed, VTK, and so forth, and then basically compile LIGGHTS. Now, notice that the first thing that the script does is create the style contact model user.whitelist, which is really what we're interested in here. So by holding Control C, I'm going to cancel the compilation and list all the files in the directory. And you notice that we have a style contact model.whitelist which has been generated. And now we're going to need this to compile LIGGHTS as a shared object. In order to do that, we need to invoke make-f makefile.shlib, and then we add the keyword auto. And this should basically compile LIGGHTS as a shared object. Now that the compilation is over, you can list the files in the directory, and you notice that we have a lib_auto shared object that's been created, and there's a symbolic link to the shared object called libligghts.so. So the final step is to install a Python module that would enable us to import libligghts into the Python interpreter. If we invoke the make command, you'll notice that there's a make install-python option. So if we look into the make file and search for install-python, you'll notice that it's the python install.py script that's being invoked by the Python interpreter for this particular option. And this script has two additional arguments that we could pass. They're not being passed in this script, so it makes much more sense to install this module by simply going into the Python directory and calling this script directly. So if we change directory, go back into the Python directory, and now list all the files in this directory, you'll notice that we have the LIGGHTS module as well as the install script that we're going to use to install the module. If we look into this script, you'll notice that there are two command line arguments that are supplied to the script. And the first one is the location of the libligghts library that we compiled. And it's important that this path or location is included in the LD library path environment variable. Otherwise, the interpreter wouldn't know where to find this SO file when it's being imported by the Python module. And the second argument is the Python directory. Now this is the location where you typically install your Python packages, such as in libsci packages, Python version 2 or 3. We're going to exit this then use Python install, and I'm gonna basically be installing this in my home directory .local lib. And the Python module usually is going to be in the side packages. In my case, I'm also going to install this locally in my home.local directory, library, Python 2.7, side packages. Now it's worth noting here that this script does not work in Python 3, although you can modify it and get it to run. So for that purpose, I'm using Python 2.7 here. And so with this, basically what the script did is simply copy the liglights SO, which is the symbolic link to the lights shared object file. It's been copied into my .local lib library directory, and then it copied the lights Python, which is this Python module that's going to import the liglights shared object, and it's now located in my side packages for Python 2.7. So this in principle should enable me to launch my Python interpreter and then import lights and just run DEM simulation, as I will show you next. So the last step is to show you how this works in practice. So I'm going to launch IPython, interactive Python interpreter, and I'm going to import lights, and you notice that it works. The module has been imported and it's located right exactly where we installed it. It's in .local lib Python 2.7 side packages. And this module provides a lot of variables and classes that we could use. The most basic class is basically the lights. Now we can pass the command line arguments to this class the same way you would when using lights as a program. In this case, I'm gonna create an instance of this called DEM. And if it works, you should get the date of compilation. This corresponds, of course, to the shared object, the liblights object that we compiled, as well as the version, and of course, the last commit. So with this, we can now use the command function to pass arguments commands the same way you would an input script file. For example, we could say atom style granular. And if it's a valid command, it'll work. Otherwise, the interpreter will crash. So this is a powerful way of running DEM simulation with lights in Python. We can also pass the input script files to the Python interpreter with the dem.file function. So to demonstrate that, I'm going to change directories and have two examples, lights tutorial, and let's demonstrate this on the conveyor. And that will basically list the files in this directory. So this is the input script file. We can just pass this as an argument to the dem.file, and then this is the input conveyor, and this should enable us to run the DEM simulation the same way we would if we were using lights as an executable.